All right, welcome to Foundations of Math 30, Outcome 30.05, Lesson 2. This is addition of probabilities involving combinatorics. So we're still going to be using our same formula that we know from before involving the addition of probabilities, but we are going to have to use permutations and combinations to help us figure out kind of all of our cases in these questions. So let's get right to it here. It says, suppose that all possible 3-digit positive integers are made using the digits in the set 1, 2, 4, 5, and 6 without repetition. These integers are individually written on slips of paper and placed in a hat. If one of the integers is chosen at random, A, find the probability that the integer is even or is less than 500, and B, find the probability that the integer begins with an even digit or ends with an odd digit. Okay, so let's just go through and figure out the super important stuff in our problem. So they are 3-digit positive integers. Our set we're choosing from is 1, 2, 4, 5, and 6. There is no repetition allowed, and we need to put one in and draw one out. And the question here is saying, find the probability that the integer is even or it's less than 500. I'll just use 500 for that. So we know that that's going to be the probability that it's even plus the probability that it's less than 500 minus the probability that it's even and less than 500. Okay, so remember, again, we want to kind of examine each individual probability on their own. So the problem here is that I have like more than one kind of number to choose from. I have different combinations or permutations, right? So I have to ask myself, does order matter? If I write the number 124, is that different than the number 421? And the answer is yes, which means it's a permutation question. So I need to permutation or fundamental counting principle. And since there are stipulations involved, we're going to fundamental counting principle this situation. So remember, still, we know that to figure out the probability of anything, it's the number of favorable out of the total number. So basically, my denominator for this question is going to be however many 3-digit integers are possible with no restrictions on them. So if I need 3 digits, I have 5 to choose from, so it's going to be 5 to put in that first spot. With no repetition means I have 4 left for the second spot and third for the last spot. And I know that that is going to remain unchanged throughout this question. Okay, so I've got that. Now I need to figure out how many of the digits are going to be even. Well, if it's going to be even, then it has to end in an even digit. So I have to have it end in 2, 4, or 6. So I've got 3 choices for that last spot. Once one of those is gone, I would have 4 more to put there and then 3. Okay, so that's an even number. The probability that it's less than 500, well, what that is telling me is that the first digit has to be a 1, a 2, or a 4, right? So I have 3 options for that first digit. Once I put that guy in, either a 1, a 2, or a 4, then I have 4 left and then 3. Okay, now this is pretty complicated, this last part, the probability that it's even and it's less than 500. So the problem is that my digits that make it less than 500, 2 of those are also even. So how do I know which one goes which? So we have to examine the cases here. Okay, so basically if it's going to be even, I have 3 cases. It could end in a 6, it could end in a 4, or it could end in a 2. Okay, those are my options that are going to give me even numbers. So that is, then you're saying you have one choice for each of those. Now let's examine the one that ends in 6 first. So if it ends in 6, to make it even, right, because that's the first part, making it even, but it has to also be less than 500, then I know that this first digit has to be one of the numbers 1, 2, or 4. So there are 3 options for this first one. It's got to be a 1, a 2, or a 4. Okay, once you place that one, of my 5 digits, 2 of them are gone, which leaves me with 3 remaining. So that tells me that I have a total of 9 options in that one case. Okay, second case is ending in a 4. So if it ends in a 4 to make it even, that means, and it has to also be less than 500 because no repetition is allowed, 4 is gone. So the first digit must be a 1 or a 2. Okay, which means that I have 2 options for that one. Once I place those two, I've got 3 remaining. This gives me a total of 6 options for that one. The last one, if it ends in a 2, and it must also be less than 500, that first digit must be a 1 or a 4. So there are 2 options for that one. And once those 2 are placed, I've got 3 left, which gives me 6. So my total for those cases is 21. Okay, so that's a little complicated. That's probably the toughest one. Maybe I shouldn't have did it as the first question, but the good news is everything after this will seem easier. So when I go through and do this, 4 times 3 times 3 gives me 36. 5 times 4 times 3 is 60. 3 times 4 times 3 is going to be 36 over 60 minus 21 over 60. So 72 minus 21 gives me 51 over 60, and that reduces to 17 over 20. Okay, my second case is saying find the probability that the integer begins with an even, or ends with an odd. So I want to figure out the probability that it begins with an even, add the probability that it ends with an odd, and subtract those that begin with an even and end with an odd. Okay, so for example, the number 245, we'd have to subtract that because we would have counted it already. So same scenario, the bottom is going to be 5 times 4 times 3, or 60 in these cases, the same as up top here, right? So that's not going to change, so I'm doing a 3-digit integer. So I'm just going to write all those in. Now, I want an even number. So beginning with an even, right? So that means my first digit must be either a 2, a 4, or a 6. So I've got 3 options for that first spot. Once that one is placed, I can place my other 4 and then 3. If it ends with an odd, well, there are only 2 odd numbers, so it must end with an odd number. Once that one is placed, I can place my other 4 and then 3. Now, if it begins with an even and ends with an odd, so if it begins with an even, there are 3 choices for the first digit. And if it ends with an odd, there are 2 choices for that one. Once those 2 are placed, there are 3 choices left for the remaining spot. And when I calculate that, I get 36 over 60 plus 24 over 60 minus 18 over 60 equals 42 over 60, which is 7/10 when it reduces. Okay, so that's a permutation question where the order matters. Let's look now at one where it's a combination question. So let's say I have 15 pool balls and we place them in a bag, and I'm just going to draw out 2 balls simultaneously. Okay, so we're going to draw a set of 2 balls. Okay, find the probability that both are striped. So probability that they're both striped or they're both odd. So I want to figure out the probability of getting 2 striped balls, probability of getting 2 odd balls. Then I would have to subtract those that are striped and odd because I would have counted those already. So because I'm drawing 2 balls, it doesn't matter what order I get them in, I just get 2 balls out of the bag. It's a combination question, right? So if I'm looking at my denominator of my probabilities, I would say, well, how many ways can I choose 2 balls out of these 15 balls that are in the bag? Well, if it's a combination question, it'll be 15C2. Okay, denominator stays the same on every single one of them. Now, the first scenario is find the probability that both are striped. So I'm still going to choose 2 balls out, but now instead of having 15 to pick from, I'm only going to pick from the striped ones. So I've got 1, 2, 3, 4, 5, 6, 7 that are striped. Then, same thing, the second scenario, I'm choosing 2, but I'm only going to pick from those that have odd numbers on them. So the number 1, 9, 3, 7, 11, 5, 13, and 15. So that is a total of 8 that have odd numbers on them. Okay, now this last part, what have I double counted? Well, is there anything that is striped and odd. Well, yes, here's one, here's one, here's one, here's one. So there's actually 4 that are both striped and odd, and I will have double counted them. So when I put all this into my calculator, this is 21 over 105 plus 28 over 105. Subtract 6 over 105, which comes out to be 43 over 105, and that does not reduce. Okay, last one here. What is the probability that both balls are striped or both are solid? Oh, those both start with an S, so let's go D for solid. You could do whatever you want to do there. So the probability that I get a striped plus the probability that I'm going to get 2 solid minus the probability that I'm going to get striped and solid. Okay, well, we know already from up above that the number of ways I can pick 2 balls without any restrictions is 15C2 or 105. You could just go ahead and write that in there. Picking 2 from the striped subset, well, if you look up above, we also did that one. There's 7 that are striped. Now the probability of choosing one that is solid, from the solid subset, there are 8 of them. Okay, now how many are striped and solid? Well, none of them. You can't be both striped and solid, so that would be 0, right? So that means that these are mutually exclusive events. There is no overlap. So if I put that into my calculator, I end up with 21 out of 105 plus 28 out of 105. Subtract 0 gives me 49 out of 105, and that reduces to 7/15. Okay, so that is probabilities involving combinatorics. You can go ahead and practice now.